we'll get to do the labs. We should be ready to do it then after that.
We are looking into details of 2 more experiments.
What do you mean?
I mean, we have 5 experiments.
No, 4. 4. So we've done 2, haven't we? Yeah, so we've 2 more to do. Okay. See. Right. Can I have a look there? Just have a look at the trig equation. So there isn't actually anything new really in this lesson, because a lot of it is just solving trigonometry equations, but by using the rules we've done so far. So let's see now. Let's have a look. We'll do number 1 to start. Although in fact I don't even think number 1 is that hard. If I said 3 cos x plus 4 sin x equals 0. Alright, this actually I think is something you could have done in semester 1. What's the trick here for solving this, do you think?
Tangent.
Yeah, so what rearrangement you would have 4 sin x equals minus 3 cos x. Yeah, so we get tan x equals minus 3 over 4. That's not too hard. We need to have 2 answers here. I think it looks like I used radians at the back, so can somebody give me what's tan inverse minus 3/4? I'll go sneeze. Wait. Say that again. Minus 6,435. And then how do we get the second answer for tan? No, that's not for tan. Not for tan. No. Plus pi. Yeah. So if you add pi onto this, what do we get? 2.498. Now, of course, there's more than these 2 answers here. If you look at the question, I said for all real values of x. So actually, you have many answers here. To get the other many answers, all you have to do is just add 2 pi to these answers. At 2 pi n. So just keep adding 2 pi. For sine, cos and tan, you get the second and third answer by adding 2 pi, because you do a 1 full circle addition. Where n is any integer. Yeah.
But the answer can only be 2, right? In quadrant 2 and 4.
Yeah, but you can loop around 360 degrees again, so it's kind of almost like quadrant.
2 and 4.
Yeah, but it's almost kind of like 6 and 8 nearly. Like you loop around again, so you're back in quadrant 2, but the angle is more than 2 pi.
Can we just do it positive and then purposely make it into quadrant 2 and 4? Like 180 minus the answer and 360 minus the answer to get the angle.
Oh, you mean the second answer?
For both answers. We make it positive and then we make it the answer in quadrant 2 and 4.
Okay.
Do we get the same answer?
I think so. I know a lot of maths books use the quadrants here more than I use them. Positive, or something like this. Yeah, if that's what you're familiar with, that's fine. But either way, this is the answer. I don't think there's anything I could say here. You know what I mean? Like, I don't think there's anything wrong with this answer. Any whole number, because you can keep adding 2 pi. Because in the question I actually don't put any limits on the x. So you can actually go all the way across the number line with multiple answers. Does this make sense or is this confusing? Make sense, yeah? That's new. What's that?
What?
What's that?
This?
Yeah. Jelly? Jelly? It's what? Indeed. Wait, you're 18 now, aren't you?
Yeah.
Oh yeah, I forgot about that. Yeah.
No.
He's 18 as well.
Yeah.
Okay. Yeah, you can't drink that anymore if you're 18.
What?
You'll need to drink something like that or water. Okay. Shall we do another one now? Let's have a look at number 3. Okay, number 3 is an example. 5 cos x plus 12 sin x equals 1. Right, now, you might be thinking this looks very similar to the last example that I did. And it does look similar, but in fact we have to do this quite a different way. Does anybody have any ideas on what to do first?
10.
Not 10.
Square them.
Squaring them is not a bad idea, but I can tell you now from picturing the steps that are about to happen, the squaring would work if these numbers were the same. Then squaring would actually work. But because the 5 and the 12 are different, when you square it, it doesn't simplify the way you would like it to. Yeah, what do you do with 13? How? Okay, good. So we have a start. We divide everything by 13 to begin with. You'll see now. Yeah, now let's draw a triangle here. And let's just call this angle here theta. And we'll call this side 5, 13 and 12. What is theta here? It would be tan inverse 12 over 5. What's that, please? We can use radians. One 1.176. Okay. So if you look at that, and you can actually check this on your calculator, if you type in cos of 1.176, you'll actually get 5 over 13. And if you type in sine of 1.176, you'll actually get 12 over 13. Like, that's a fact. That's a fact. So what I'm saying is that 5 over 13, in a sneaky way, you could replace it with cos of 1.176. Cos x. Plus, and you could replace that with sine 1.176. Sine x. And that's equal to 1 over 13. Now you might say, well, what's the point in doing that? Well, you see what you've done is you've tricked it into being like a cos A, cos B plus sine A, sine B. That would be cos A minus B. Now, I'll actually call this A and this B. And I'm allowed to do that because I can swap cos, cos, and I can swap sine, sine. So this will be cos x minus 1.176 equals 1 over 13. Now, that's a lot easier to solve. When you cos inverse 1 over 13, what do you get? 1.494, or 2 pi minus the first answer. Say again? Now, how do you make the extra answers? What do you add here? You add 2 pi, don't you? Yeah. And you can add as many 2 pi's as you like. Could you get the door there, please? Yes, thank you.
We need to find the x, right?
Yes.
Actually,
Hey.
I want this first, like, second.
Me?
No.
Oh, you need to talk to
Yeah.
them? Sure, go ahead. Yeah.
Hey guys, I just sent a link for you guys maybe last week or earlier. I need you to submit your final choice.
So we didn't got any feedback from each other.
For what again?
We didn't got feedback from each other.
From what?
They've not had tutorial with Isabel for a couple of weeks.
Your predicted grade.
I know, I mean about our university choices, because you said you passed for something, but we didn't got that yet.
No, you probably had your tutorial about your predicted grades already.
It's just that our choice.
Yes, you have your predicted grades. You have talked with the universities doing the fair, so you now should be able to make your final 3 choices.
Yeah,
Okay.
I think the only thing is maybe Isabel would have wanted to double check that your choices are sensible, but I suppose you'll see that too
Yeah,
when you're
I will,
making it.
yeah.
I'm sure Tiago will be in touch with you if he thinks there's something
Yeah.
unusual about the
Exactly,
application.
yeah.
So you know your predicted grades. You talk to the university, so you all should have an idea of what your choices are. So you need them to fill in a link or something.
Yes.
You
I
email
sent
the
a
link.
Yes.
Yeah, okay.
They all have a link. You just have to click the link and fill the form and then submit. But guys, I need that by the end of
Yeah.
the day.
Yes. Yeah.
Okay? Yes, please do it.
Is this like a Google
Like a
Doc?
Google form, yeah.
Yeah, Google form. Okay, so you
Pretty simple.
must fill out this application form, and if you check your email and for some reason you don't have it, should they
Just
email
let
you?
me know, yeah.
Yeah, just email Tiago if you for some reason don't have it in your
I
inbox.
need that because we have to start to make our applications for the Irish universities. So we really need that now. Okay?
Just to be clear, even if they're applying for the UK, you still need them to do the
Yes.
form today. Yeah, so
Yes.
UK or Ireland.
All of them, yes.
All of them, okay. All right, thanks.
Thanks, Jim. Thanks, guys.
Okay, so as we were saying, did you get that in your inbox?
Yeah.
I got it.
Yeah, okay. You can do it after this class. Once you have it, that's the most important thing.
And why is that also she wants to?
She probably just wants to double check your choices before you fill in the form. But I'm sure you would have talked about your choices already.
Is that how
Yeah.
the final choice? Right.
Well,
No, it is not. Because you still have to fill in your cup by ourselves.
You got it.
yeah, but you know, the school is going to help you with your application. So as you heard, he wants to start this week processing the applications. So he might not appreciate if 2 weeks later you change your mind after he contacted
Okay.
DIT or whatever, you know.
I don't know.
No, I mean we already gave him our choices, the first choices. Yeah, that was our final.
Yeah, I don't remember, it's a while since I did it, but I think you first submit your choices, but then you have to submit what you want to be your first choice and your second choice.
We have your favorite, no?
Yeah, I mean, what I mean is about our first choices and our voluntary and non-voluntary fair. Isabel wants to talk about all of them together, but we cannot.
Yeah, maybe Isabel just wanted to talk about maybe after the fair you might want to change your mind. Did anybody change their mind following the fair?
Yes.
No.
Yeah?
I changed mine.
You changed from where to where?
I changed from, no.
Where's
From
your
UK,
choice?
UK to Ireland to 80% Norway.
So you already like 90% NUI.
Yeah.
So what's your first choice?
NUI. What's the second choice? NUI. That's the lowest I know.
Second choice.
Limerick.
DCU?
First choice is NUI Galway. Yes. And your first choice, Monica? Belfast Queens. Yeah. What course there? Okay.
I thought that was the
And what's your first choice, Chu, for university?
IT, Carlo.
Carlo, great. That's very near where I live. I could see you sometime. That's only 15 minutes away from my home.
Really?
Yeah, you could drive in 15 minutes.
Private tutor.
Yeah.
So those still
Yeah. You can come visit me. Yeah, when you get your car. Yeah. And what's your first choice? Bradford.
Yeah, but they withdrew the EE.
Course.
Yeah, so I have to apply.
A different one. And what's yours? What course? Yeah.
Anyway.
What's up there? What's up there?
And yours?
Manchester.
I told you.
Did you study in Ireland? Which university is better for computer science? I mean like NUI or DCU or... Definitely not UCD.
UCC.
I think, to be honest, for engineering, it's really hard to beat Galway and Limerick and Cork. Like, I would say it's probably like Galway, Limerick, Cork, or something like that for engineering. But I think when you consider all the factors, maybe Galway's a good choice for engineering. Because, it's not just the course, but it's also the facilities, the fees, the living costs. When you put all the factors together, I think for engineering, I always recommend students to look at Galway.
Yeah, Galway is between 500 and 550.
Yeah. But it's not as expensive as Dublin. So it's good value. And the students always enjoy their experience in Galway.
But there's only one Chinese supermarket.
Is it better?
It's no.
Jerry,
What's the Korean market?
just be thankful that there is one Chinese supermarket. Just be happy that there is one Chinese supermarket.
Yeah.
Some people
There's one
Like,
Korean market.
if
in
somebody asked
Galway.
me how many Chinese supermarkets there are in Galway, I would have said 0,
Zero Korean market in Galway.
Yeah.
But they can change the price of the food, whatever they want. That's just only one.
Oh, I'm on curious.
Only one in Galway.
I'm going to go with.
Why?
No, I mean I'm paying a visit to go. Oh.
Just to finish this one here as an example, we're nearly finished, but remember these two answers are for x minus 1.76. So to finish, just add 1.76 to each of these, please, and tell me what you get. The 1.494 and the 4.789. Or
What?
I'm adding the 1. Wait, that's not right. Is that for this one?
2.67.
Okay. Well, what's the other one then?
2.67.
2.67.
Yes.
Either of these, okay? Yeah, plus 2n pi, where n is an integer. So you've got again many answers here. Okay, let's do
So we can just leave the answer like this.
Yeah.
Oh.
It's just to be clear what I'm saying, Lee. The answer is this or this, and then you have many more answers. So either of these plus any multiple of 2 pi is an answer.
Okay.
Yeah.
But we have only 2 pi maps in a circle.
No, you're allowed to
Spin
spin a loop around you. Yeah. So I think we'll have a look at
How about the changing?
Which one's that now? Which number? See, I don't see one with tan in it. Now that doesn't mean that there isn't a question with tan in it. Like,
Number 9.
Number 9 is not as hard as it looks, believe it or not.
11.
11 is as hard as it looks.
Let's do 11.
No, I'll leave you to try those ones. I will do 5 now. Can I scroll down?
Yeah.
Yeah. Okay, 5.
Teacher.
Yeah.
In the previous question, how do you get 4.789? Plus
2 pi minus the first answer. This is how you get the second answer for cos.
why?
What was that?
We did this in semester 1.
Oh.
Yeah.
Okay.
But
There should be one more.
just Lee, if you're going to be using quadrants, the reason is for cos it's positive. In the first quadrant it's positive, and in the last quadrant it's positive. And this angle here matches this angle here. So to get this, it will be 2 pi minus your first angle.
Okay.
Yeah. Can we go on to the next one? Let's have a look at 5. Cos 5x plus cos x equals 0. Alright. What do you think we have to do here? Now this one you might think, well, this seems easy, just divide, bring the cos over, but the big problem is actually, you can't do that, yeah. Kind of have to do something like this, but not quite this. Huh? Yeah, unfortunately, not quite as straightforward as that. Very good, very good. But not quite. You're very, very close. You're very, very close. You should change 5x into 3x plus 2x. Because then for the other one you can just say it's cos 3x minus 2x. Now you might say, well, why does that matter? Well, watch what happens if you use compound angles. Cos A cos B minus sine A sine B plus cos A cos B plus sine A sine B. Now that's very helpful because two things cancel here. Can you see that this piece will cancel with this piece, and these two are the same? So you end up with 2 cos 3x cos 2x equals 0. Which means you have two equations now. Cos 3x equals 0, or cos 2x equals 0. Got that? Yeah? Now, we've turned this into simpler problems. Here, I know when you do cos inverse 0, you get 0. No, that's not true, sorry. You get pi over 2. But the second answer, when you do 2 pi minus the first answer, is 3 pi over 2. And here we get 2x equals pi over 2, or 3 pi over 2. Now, how do we make the extra answers for cos? Well, no, we just have to add pi over 2 or 3 pi over 2, add 2n pi. But then, of course, we also, don't forget, we have this one here. 2x equals pi over 2 or 3 pi over 2 plus 2n pi as well. Nearly finished. We have to divide here by 3. So a 3 goes here, and a 3 goes here, and a 3 goes here, and a 2 goes here, a 2 goes here, and a 2 goes here. So you end up with saying x has to be pi over 6 or 3 pi over 6 plus 2/3 n pi, or you could have pi over 4 or 3 pi over 4 plus n pi, and n is an integer. So you have 4 basic answers, and you can add multiples onto that as many times as you like. We got the idea here?
Actually, in exam, I think the question probably will show the range, right? So we know to range.
Yeah, you see, for these questions I said x is a real number.
Okay.
Now, typically they specify a range, like from 0 to 2 pi. But the problem is, in the syllabus, there's nowhere that says students must learn only that. Do you know what I mean? Like, there's nothing in the syllabus that says students must solve equations within a range. So when I was making this worksheet, I realized, oh, I never actually showed you what to do if there was no specified limit on the range. So it's not, in some ways it's actually easier, because I can just say, oh, plus 2n pi, and that's it, as many times as you want. Whereas when you actually do have a range, you actually have to kind of work out the different values of n. Okay, did you write that down? Yes? Yes. So, you were asking me about number 9. Well, 9 first. In 9, what you should do is bring the 2 to the right, and then add the fractions together. And you'll discover actually what simplified. 10 and 11 is quite tricky. If you manage to get that, congratulations.
It's also an effort.
Yeah. It's extremely difficult. Yes, yeah, and there was something else to do in tutorial this week that Jerry wanted me to do from last week.
Yeah, minus 1.
Huh?
Minus 1.
Yeah. So let's see. Do we have classes tomorrow? Like a math class tomorrow? What time? Oh, that's right.
So he said we don't have, but that's not correct.
I don't know what the plan is for this week. So do you know what, actually, I I have more time available. I feel like I have more available hours in the physics than I do in the maths. Because we're making fine progress in the maths. But as you can see, we're halfway through this book. Whereas for the physics, we're 2/3 of the way through, although we still have to do the lab, so it's not quite 2/3. So actually, do you know what I think I'll do instead? In case things get moved around this week, after lunch today, we'll have 2 physics classes. But what I'll do instead is I'll change one of them into a maths tutorial, and then what have we to do with the assessment support? Oh, the maths. Did you finish it already?
Yeah.
Did everybody type up everything? But you haven't finished?
Typing.
You're typing.
Yeah, but I'm not missing captions.
You have a pen and paper copy that I can check? So what I can do today after lunch, we'll have a tutorial in one of the classes. After lunch, for maths. And in the second class, what I can do is, if you have your coursework finished, even if it's not typed, I can print out the marking scheme and we can sit down and we can check it together. Yeah? Yeah, go on.
You don't do the physics? You don't cover the lab?
The lab? Well, I mean, I could do the labs, but then I realised I haven't actually arranged when we will do the labs. So I think, do we have physics on Thursday? I can't remember, but there's one particular day where you have like 2 hours with me, and then you're free for an hour or something. That's Wednesday, was it? Yeah. See, because what I'm thinking is, I just need to have the labs finished before that Wednesday, which will be next week. So, if we have physics on Thursday, do we?
Thursday, Friday.
We have physics. Fine. So then on Thursday we'll do lab 3, on Friday we'll do lab 4, and then we'll be ready to do the labs next week then. And we'll do maths after lunch then, today. We have a little bit of time? No, not really actually. Now, in the exam, these questions can be a little bit tricky. Of course, they're not as hard as 10 or 11. The type of questions I see in the exam are more like the ones that I just did now, but they usually give you a range in the exam. Now, just looking at what's coming up, the next topic, there's only 2 topics left in the trigonometry. The next one is all about proofs. This students find difficult, of course, in the exam, but at least in the exam the proofs are not too long or too big. So it's actually not too bad. 62 is very tricky, especially question 3. The weird thing about integration is you can't always tell how hard it is. So you might look at this and think number 2 looks harder than number 3.
But it is not.
No, number 3 is much harder than number 2. So this is the crazy thing about integration. You can't always tell from just looking at it if it'll be an easy or a hard question. Wasn't there some question that we had in integration that needed by parts twice and implicit differentiation twice?
The mistake one.
Yeah,
The mistake question, yeah. But it was only a small mistake, but the small mistake made the question so much harder, you know. How are we doing in maths? We have vectors to cover, and after vectors we have statistics. Yeah, but vectors is a big chapter and statistics is a big chapter, isn't it? Yeah, normal distribution is like probability, it goes with statistics. It's a bit, the normal distribution, they just stuck that in as a new topic recently. Do you know what I mean? Like it was just thrown in as an extra topic. So, and students usually do a bad job of it because they don't care about it. Because it's more of a business maths topic. But it does come up in engineering, and I guess that's the reason why they wanted to include it. But the next chapter, vectors, is very, very, very important for engineering. We're going to be looking at vectors, and you might say, well, we look at vectors in physics, but this is more advanced vectors, and it's also in 3 dimensions, x, y, z. I think, Jerry, you were asking me about that, weren't you, the vectors? We'll have them in x, y, and z. Yeah, 3D, yeah. And the vectors that we do is not even as hard as it gets, because we're only actually doing kind of an introduction to advanced vectors. Anyways, please try those questions we did, and we'll do the tutorial first, and then if you can bring your laptop, or well, actually, do you have your laptop today, or what's?
Yeah.
Of course not.
No.
Well, can we do
It's
math
hard for me to
tomorrow?
calculate today.
Let's just move on to
Well, hang on, let me.
let's finish the Trig today and
We can't. Oh.
and then do math tutorial all together.
No, because
tomorrow.
Jerry's been asking me for that question for a while. I really want to have a maths tutorial. I'll do a maths tutorial. Well, hang on, how many people actually would be able to show me their physics later?
Basic?
Sorry, maths later. You could show me. You can't show me. You could show me. You could show me. Yeah, okay. So we won't do that this week. Instead, we'll do a maths tutorial, and then we'll just do the next maths lesson. Actually, yeah, no, I can't do the physics labs because I need everybody here to see it.
Yeah.
Yeah. So we'll do double maths after lunch then, okay? All right.
Teacher, what's the problem with the